Okay, kick off dynamics, just do some simple conversions. So just have to do a little bit of maths before we kick into dynamics properly. I just wanted to go over some conversions that we'll use for converting time and speed and acceleration. Just make sure we can all do it. And so let's just start with something simple. Convert 1.25 hours to minutes. So the first thing to think about is, okay, this 1.25 hours does not mean 1 hour and 25 minutes. There are 6. So this is 1.25 hours. So it's 1 1/4 hours or 1 25 hundredths of an hour. Remember, there are 60 minutes in an hour. And so when you're doing this one, you can use the same old stuff we did last time. So we're doing 1.25 hours to minutes. Then we can think, right, so 1 hour is equal to 60 minutes. So what have we got? So therefore we're going to do this remember we did this before, 1.25 hours. So this was right at the start, week 1 or something like that, times. So we're trying to get rid of the hour, so it's going to go on the bottom. So we're going to do 60 divided by, so 60 minutes divided by 1 hour. So I'm just taking this here, turning it into a fraction. So therefore it's equal to, so those hours are going to cancel out. That's why we did it. So it's just going to be equal to 1.25 times 60 minutes, which is going to stick that in the calculator. And well, actually you can figure it out. So it's 1 hour and then you've got 1/4 of an hour. So that's 15 minutes. And so it's going to be 60 plus another 15, which is 75 minutes. Too easy. Underline your answer. So for the next one, what are they asking us this time? Convert 315 seconds to minutes. So we're going to go 315 seconds to minutes. Let's just write it the same way as we did last time. So 350 seconds to minutes. So we know that 1 minute is equal to 60 seconds. So therefore we're going to get 315 seconds. Let's just leave a gap, same as we did before. 315 seconds times. So we want the seconds on the bottom. We want minutes on the top. Those are going to cancel out. That's why we did it. So that is going to be equal to 315 times 1 divided by 60 times, and this is in minutes. Okay, so I'm leaving my units in the equation because it just keeps track of what's going on. So you're going to have 315 divided by 60. I'll just get my calculator. I should be able to figure it out. It's going to be 5 1/4, isn't it? 3, so 5.25, 315 divided by 60. Yeah, it's 5.25 minutes. Now again, this doesn't mean 5 minutes and 25 seconds. It means 5.25 minutes, 5 1/4 minutes, 1/4 of a minute is 15 seconds. So there might be times where you want to write it like that. So it's the same as 5 minutes and 0.25 times 60 seconds is what 1 minute would be, which would be equal to 5 minutes and 15 seconds. Okay, so heaps of different things to do, but in this case it's just asking us to convert it to minutes. We want to leave it as a decimal. Okay, and the decimal numbers after the decimal point are hundredths, but minutes are 60ths, or seconds are 60ths of a minute, so you just have to be careful with that. Okay, next one, convert 60 kilometers an hour to meters per second. So we're doing C. So we're 60 kilometers per hour, and I want to convert that to meters per second. Now, I could try and figure out how many meters per second are in a kilometer per hour, but let's just do it step by step first. So let's change it. So we're going to have to get meters per second. Let's change it to meters per hour first. Okay, so we know that 1,000 meters is equal to 1 kilometer. And so let's change this first. So we're going to do 60 kilometers per hour times. So we're going to try and get rid of that kilometers and change it to meters, because we're wanting to end up with meters per second. This here. So we're going to do, so just do the meters first. So 1,000, we're going to get rid, yeah, that's right, we want meters. So it's going to be on the top, divided by 1 kilometer. That's just equal to 1. Remember why we're doing this. 1,000 meters over 1 kilometer is just, these are the same thing. 1,000 meters, kilometers, same thing. So this is just 1. So you're not changing anything. All you're doing is changing these units. So then I'm going to get my kilometers cancelling out. So this kilometer is going to cancel with that kilometer. But here, do it in grey, I've got my meters. So that's going to change to 60 times 1,000. And we've now changed it to meters. We haven't dealt with the hours yet. Per hour. So it's going to be 60,000 meters per hour. Now, that means we go 60,000 meters in every hour. We want to change this to seconds. So what we know is 1 hour is equal to 60 minutes. And 1 minute is equal to 60 seconds. So that's going to be equal to 60 times 60, which equals 3,600 seconds. Now we have to try and figure out, well, we could still use the same rule. So we want to change this to meters per second. So we have got 60,000 meters per hour times. Now, we've got an each dividing, so we want to get the hours on top. So what we've got here is 1 hour is equal to 3,600 seconds. So we're going to put the hour on top, so it's going to be 3,600 divided by seconds, divided by, oh, sorry. We're trying to get rid of that hour. That hour has to be on top. So therefore, we're going to have 1 hour over 3,600 seconds. And that's just equal to 1. These two things are the same thing. 1 hour is the same as 3,600 seconds. And I've put the hour on top because I want my h to cancel out. So that is going to cancel with that. And it's going to be equal to 60,000. And now divided by 3,600. And we're going to have, so we've got meters up here, seconds down here. So it's going to be changed to meters per second, which is going to be equal to, it's going to be 600 divided by 36, whatever that ends up as, 50 or something like that. Let me just have a look. 60, 1, 2, 3 divided by 3,600 is equal to 16. Interesting. Yeah, that makes sense. 16.67 meters per second. Now we could do a quick check on that. So let's just check it in our heads. Let me just do it in grey. So let's call this a check on this one here. So we've got 16.67 meters every second. So every second it's going to go 16.67 meters. So every minute it's going to go 60 times that. So it's going to be 16.6, I'll do more accurate, lots of 6s and a 7, times 60 will give us meters per minute. So that's about 1,000 meters per minute, which is about, so every minute it's going to go 1,000 meters. So every hour it's going to go 60 times that. So it's going to be 60,000 meters per hour, and we know that there's 1,000 meters in a kilometer, so that's just going to be 60 kilometers. 60 kilometers per hour. Okay, so you don't even have to use this method. You can do it in your head just by thinking about what does this mean. Well, it means it's going to go a meter every second. So you can figure out how many meters it would go in an hour. Therefore, and then you can change that into kilometers. Okay, next one. Wind has a maximum speed of 30 meters per second. What's the wind speed in kilometers per hour? So we want to convert 30 meters per second, and we want to change that into kilometers per hour. Okay, now what I do to avoid getting tiny little numbers, I'm actually going to, so what I'm thinking is goes 30 meters every second. I will use this way of doing it just so I'm consistent the whole way through. If you're getting used to this way of doing things where you write down the fraction and you times by whichever one you're trying to get rid of. But we could do this in our heads, I think. So let's just, but anyway, so what I would do first is, I'm thinking it's 30 meters every second. If I change the meters to kilometers, I'm going to get some kind of fraction. 30 meters is 0.03 or some decimal. 30 meters is 0.03 kilometers, I think. But I'm going to try and avoid getting little decimals. And so what I'll do is I'll get rid of the seconds first and change that to hours. So we should be able to remember that, and it's worth remembering, 1 hour is equal to 3,600 seconds. Gives you 60 times 60. So therefore we are going to get 30 meters per second times, not changing anything, if we times it by this fraction, 3,600 seconds over 1 hour is 1, so you're not changing anything, they're both the same thing. We've got seconds on the top here, seconds on the top here and on the bottom here, so those will cancel out, and so therefore we are going to get 30 times 3,600, so just bring the numbers out first. Let me just bring this down. Then on the top we have got meters was on the top and we've got hours on the bottom. So 30 times 3,600 meters per hour. I could calculate that. It might have been better to change the other one first. But anyway, let's just write it out. So 30 times 3,630 is equal to 108,000, sorry, meters per hour. And then we can change that to kilometers. I think we can just do that in our head. We don't need to do the whole fraction thing. There's 1,000 meters in a kilometer, so it's 108 kilometers per hour. What I did forget to do was to underline my answers up here, so just underline that one, because I want you guys to remember to do that both in the exams and the tutorials. And we'll do the same here. So we could, in this one, it was a question, so we could write our answer as a sentence. Wind speed is equal to 108 kilometers per hour. So it's a pretty fast or pretty strong wind. So for this last one, it's an acceleration. So in this course, we're not really going to, well, we're not ever going to be converting between an acceleration in meters per second squared and change it to, I don't know, kilometers per hour squared or something like that. Our accelerations will pretty much always be given in terms of meters per second squared. But anyway, so what we'll end up doing is we'll do a calc. I just want to talk quickly about what acceleration means. I know you all know this, but let's just go through it anyway. And then we'll calculate this, and what you'll do is you'll calculate your answer and then you'll convert it to kilometers per hour at the end. So let's have a look at that. So we've got a car that's accelerating at 1.25 meters per second squared. So our acceleration, the symbol for that's usually A, is equal to 1.25 meters per second squared. What does that mean? It means that it's accelerating of 1.25 meters per second, and it's increasing its velocity by 1.25 meters per second every second. So after 1 second, it'll be going at if it starts at rest. After 1 second, it'll be going at 1.25 meters per second. After 2 seconds, it'll be going at 2.5 meters per second. Then it'll be, after 3 seconds, it'll be 3.75 meters per second. So every second, this is how much the velocity is increasing. Okay, that's why you get this square down here. It's meters per second. So it's meters per second squared. Now, so basically we'll learn this in a minute, but if it starts at rest, then the velocity, to calculate the velocity, you just do acceleration times time. Sure, you all know this. Acceleration times time. So we are needing V in kilometers per hour after 20 seconds is what we're trying to figure out. So we're going to do 1.25 times 20, which is equal to, that's 1.25 is 1 1/4, you can do it in your calculator, but whatever, 5, so it's going to be 25 meters per second. Is what the speed it'll be going at after 20 seconds. And we're going to change that to kilometers per hour. So V is equal to 25 meters per second, which is equal to, so what we can do is, let's change to hours first. We're looking for kilometers per hour, so let's change to hours first. Excuse me. So 3,600 seconds is the same as 1 hour. It's just 60 seconds times 60 minutes. So therefore, we're going to have V is equal to 25 times, oh, well, 25, keep the units in because that's what we're doing. We're stuffing around with units. Meters per second times, so we want to get rid of those seconds and get hours, so we want to put that 3,600 seconds on the top, so those cancel out, and divided by, and we want the hour underneath, which is equal to 25 times 3,600. 25 times 3,600 is equal to 90,000. So that's 90,000 meters per hour, because the seconds cancelled out, so I'm left with meters per hour. Meters per hour. And so that is going to be equal to, so we don't really need to do it, do the fraction. We can just say, well, it's 90,000 meters, so that must be 90 kilometers per hour is going to be the velocity of the car after 20 seconds. It's going pretty fast. Yep. So velocity, did I ask for velocity or speed? Speed, so better say speed then. So velocity, you should really have a direction, but speed after 20 seconds is equal to 90 kilometers per hour. Done. Okay, so I think next we're going to have a quick look at solving quadratic equations, because we're going to need that as well, and then we'll get on with some proper dynamics.